So we are testing this hypothesis for population mean that mu is 60 and versus mu is greater than 60. Our level of significance is 0.05. The population standard deviation is given to be 15 and the sample size is 40. So what we would like to do here is this, that we would like to calculate the probability of type 2 errors for various values of mu's, and then that type 2 error occurs when we do not reject a false null hypothesis, right? Okay, so first let's see that in this situation, when are we not going to reject the null hypothesis? Okay, so what we are doing is our sample size is 40, so we are going to obtain a sample mean of x bar, and we shall not remember this, we reject if the sample mean just goes towards the tail, where this tail is 0.05 in area. That is, if sample mean goes to the right of this cutoff value, we reject the null, and if it goes to the left of this cutoff value, then we do not reject it. Or in other words, if x bar is in the 95th percentile, right, of this normal distribution with mean 60 and standard deviation how much? What is the standard deviation of sample means? 15 over square root of 40, that is sigma over square root of n. So if that happens, then we do not reject the null. So let's go ahead and calculate the 95th percentile of this normal distribution, whose mean is 60 and standard deviation is 15 over square root of 40. So let's use Excel to get this 95th percentile. So what I would do is I'll click on this, which says insert function. That means what I did was, let me just show you. So I just went ahead and clicked at this icon, and this is the, this one just lets us insert a function. So we will choose a statistical here, and then we will go ahead and choose inverse norm or norm inverse, and here norm inverse. So, and in here we shall first type our percentile, that is 0.95, then the mean is how much? 60, and the standard deviation is 15 divided by square root, we'll just write SQRT for that, 40. All right, so what it comes out to be, the 95th percentile is that if the sample mean turns out to be less than 63.9, that is, it is in this region, then we shall not reject the null. All right, so what we are going to do now is, so to calculate the probability of type 2 error, and that type 2 error would be, would occur when null is false, but again, it's going to depend on like how badly the null is false. For example, let's obtain this, the probability of a type 2 error when the null is, or mu is in fact 61 units. All right, so let's see what the probability of type 2 error is. That is the probability that we won't be able to reject this null hypothesis. So here we have actually the mean equals 61, and what we are going to do is that we are going to find the probability that our sample mean will turn out to be somewhere on the left of this 63.9, or the probability of what? This region. So what this region is, that this region is the probability that the sample, sorry about that, that the sample mean is less than 63.9 if what? The population mean is 61, and of course we are taking the same spread, so that is this is 15 over square root of 40. So we'll go back to Excel and obtain that probability, and I have listed, let me take you there first. So actually I have not listed, I'm going to list. So here 61, say we are calculating it for various values. So say for mu equals 61, 62, and let's go up to say 75, and here you can see 75 is like a very bad value of null hypothesis in very bad value of mu in this case, and there, or in other words, null is really badly wrong there. So when we are computing the probability of type 2 error for the actual mean to be 61, so what we would do here is that here we will go to the normal distribution, right? So here is normal distribution. What we want to do is this, that we want to find the probability of the area to the left of 63.9 when the mean is 61 and the standard deviation is how much? The same. Okay, so a square root of how much? 40. Now since we just want to do it like all together, or automate this calculation for the mean, let's just click on this cell, so that way we wouldn't have to retype it again and again. And here I had made a typing mistake. Okay, I wrote 4 instead of 40, and this is, we want to know the cumulative probability, so we'll say true there. So the probability of type 2 error is how much? 0.8893 approximately. Then what the power of the test would be? That is 1 minus this probability of type 2 error. So the power is not really that great, and the probability of type 2 error is, yeah, that does look, quite big. And if you do this, just drag it down, so you get the probabilities of type 2 error for all these possible scenarios. And again here you will get the power for all these, and for all these situations. And if you want, you can just go ahead and make your make a curve which shows you the power for all types of departures from the true value. So what we should do is, let's just make a scatter plot, right? So here we go, and then so this is the chart showing us the various values, right? Okay, let me just bring it over here, and we can go ahead and format axis in a manner that is, let's start it at 60, stop it at 74. So here you can see that the power of the test increases as it as it becomes more and more wrong, whatever kind of language that is, and the probability of type 2 error also decreases with the departure of the value of mu from the hypothesized value of null. All right.